Good day and welcome back to Tech Tips, Fixes and More. My name is Ron, and if you have been watching some of my videos up until this time, you probably have heard me say, well, I've got something different for you today. And that's true of this video, but in a different way. This video was filmed several months ago and involves the repair of two console stereos from back in the 70s. And this one is different in the sense that one of these consoles I worked on for quite a long time, and in the end was just not able to fix it for a variety of reasons, lack of schematics, difficulty getting parts, and just the nature of the problem. I worked on these two stereos for quite some time. The first one I learned a lot, but that first one I was not able to get working. The second one I was able to find the source of the problem, get it working for the customer. So I'll try to include the information on both of these fixes in the same video. There were some parts where I was not able to get footage of the actual testing and repairing, but I have some explanations and descriptions of what I did. We can all learn from those situations where we aren't successful, and we can learn from the ones where we are. So let's take a look and see what happened. Well, good day and welcome back. Today I'm working on some older component stereos. Now these things come from the early 70s, and as you can see here, I've got two of them in my shop. These are Electrohome stereo units that include a tuner, an AM/FM tuner, an amplifier, and a turntable, a changer phonograph. And both of them are not working. Their problems are slightly different. I'm going to be taking a look at this first one here, which the changer is not all there, and I don't know whether it's even possible to get the mechanical parts for the changer, but I'm hoping to get it back to where it'll actually at least play in manual mode. And I did plug this one in. It's definitely not working. There's a bit of a hum coming out of it, so I suspect some power supply problems. So let's jump in and see what we can find out. We've got a set of buttons down here that say circa sound, and it's got int off, then right, left, and it says REM for, I suspect, remote. So let's just okay, so we've got a bad hum, and that hum goes down when the loudness control is turned down. It responds to the bass too, and you can tell the difference when you adjust the treble. It's this pot is dirty, but it appears to be there no matter where the balance control is set. Interesting, when you put it on mono or release the mono button, it goes away. Oh, again, and this has to do with this balance control being intermittent. But it does seems like it's happening more on one channel than the other. That may be because this speaker is only connected to one channel. So we're going to have to get the circuit boards out of this and maybe get it on the bench and take a look. So here's the bottom side of this stereo. There's some information along here. We've got the model number. It's a 703A, I believe, circa 75. Information about the finish and so on. It's made in Canada, and there's a serial number on it. We've got an access hole here where you can access tape output, tape inputs, and it looks like there is a provision for a flat antenna cable, and there is an antenna installed inside of here. That would be for the FM. We've got a panel down here that's covering up the electronic unit, and we're going to have to take that off. It's a little hard to see from this angle, but there's a speaker down near the bottom here. So I'm going to take off this panel, see what I can find out there. Also, we have connections over here. There's an antenna connection for, it says FM on it. There's also a bunch of RCA jacks for remote speakers, it looks like. Right, left, right, left. One is called satellite. One is satellite, and the other says remote, or REM for remote. And this is interesting. Inside the panel we have information on the placement of parts. Okay, so I got the AM/FM tuner, amplifier, power supply, the electronics module out of the console stereo. I also got the phonograph part, the turntable out, and we've got them on the bench now, and we're going to see what we can find out. So this is going to be an interesting exploratory operation. We do know some things. There's information we do have that will help. We had hum, and that sounded like 60 cycle hum, which would make me think that we have a power supply filter problem, and that makes sense because old amplifiers or old power supplies and their capacitors tend to dry out, especially the older types. And when they dry out, they basically go faulty, and often with amplifiers you need to replace the capacitors. And so as you can see right here, we've got one large can capacitor, and we've got a couple of these ones in cardboard cylinders, and so those are obviously pretty old, and if this thing was made in the 70s, that stands to reason. Also, we have these blue caps down in here, and as I look at them, see if I can get a close-up shot of it, it looks to me like the ends of those caps are popped out, and that's usually a pretty clear sign that the capacitor is faulty. So I'm going to take a look at some of these, put them on my cap checker. I have to remove them to do that, and we'll see if we can gain more understanding of some of the possible problems here. We're going to pull out the cap checker and just see what this thing says. This is an old cap checker that I built many years ago. It's nothing too sophisticated, but it does a reasonably good job of checking the value of the capacitor. That indicates that it's running at about close to 2,000 microfarads. Which is high because it's a 1500 microfarad capacitor at 20 volts. Now these old caps, as I remember it, they used to have a tolerance of something like plus or minus 20%. And so if you had a 1500 microfarad capacitor, it could be anywhere from 1200 to 1800, and actually this is fairly close to that, so that cap might be okay. It still could be leaky, and so we'll check the other one. So that one's similar. So these caps, I will probably do an ESR test on these as well. They say it's a good idea to not only test the actual capacitance value of these capacitors, especially these old ones, but to also check the ESR, which is the equivalent series resistance. And basically what that's measuring is the resistance of the dielectrics inside the capacitor at a certain frequency. With an older cap, they'll dry up, the dielectric will degrade, and your equivalent series resistance can go up, in which case the capacitor won't perform correctly. So these little testers, this is a little tester that I built out of a kit a number of years ago. It will basically check that. You zero it out and then you connect it up to the capacitor and you see what the equivalent series resistance is, and that basically is telling us that the ESR of this cap is 0.09 ohms, which is well within tolerance. It's no problem. The ESR meter comes with a handy table silk screened onto the front of it, and the table tells you what the approximate worst case ESR values are for new capacitors at 20 degrees C. Down the side of that table you've got capacitor values, and across the top is the voltage rating of the capacitor. And so in the table then you can find the value of the capacitor and its associated voltage and find out what its ESR should be to see if you're close to the correct value. You don't see too many of these boards anymore. In fact, you never see them. This is actually a phenolic PC board, and they were used extensively in this era. The problem with phenolic is that it's pretty brittle, and it's easy to crack the thing. If you drop the circuit, you can actually crack it, and that can cause you all kinds of problems. So this is a two-section cap. It's a Mallory cap, which one part of it is 1,000 microfarads at 40 volts, and the other part is 4,000 microfarads at 40 volts. So that's a pretty big cap. And this one is about 0.08, I mean, and that one is 0.03. So again, the ESR seems to be fine. 8,000. Yeah, so this is looking like this, like 8,300 microfarads. Seems like it's 3 or 4 times as high as it's supposed to be. I'm going to guess that that capacitor is bad. I'm not sure if you can buy those exactly that way now. Probably have to buy 2 capacitors and make them fit in there. Maybe we'll check some of these other smaller electrolytics. Okay, so this cap is a 80 microfarad at 25 volts. Yeah, so that's saying it's 130 microfarads, quite a bit over what it's supposed to be. This one is not looking very good. It's almost like the end's been blown out of it, so I expect this one's bad. I don't know what it'll read, but it looks bad for sure. Oh, 130 as well. Interesting. Okay, so at this point in the process, in a way I was kind of flying blind. The testing I was doing at this point was based partially on visuals, what some of those caps looked like, and just trying to make some educated guesses. The metal can cap, which is a two-section cap, was in the power supply. It's a negative ground power supply, and it read very high. And so I got a hold of some capacitors and put them in. I had to use two caps to replace that one cap. I ran into some problems with the phenolic PC board. The traces on those boards come up very easily if you get a little too much heat on them, so I was struggling a little bit with getting the new caps connected in properly. But I did get some in there and tried it. It seemed like that got rid of some of the hum, but it wasn't solving the problem. The two capacitors that had cardboard cylinders on them, those were output coupling caps to the speaker outs, and they seemed like they read okay, but I replaced those as well. The 80 microfarad capacitors, I believe, are coupling caps in the amplifier section, and because I had no schematics, I couldn't really tell exactly where they were, but I replaced basically all of those. There were 7 or 8 of them, and so I replaced all those, and somewhere in the process of all of this I started running into other problems, and that may have been introduced by me, problems with the PC board. Maybe I did something wrong, but anyways, it just seemed to go downhill from there, and I was not able to come up with a solution. I kind of got to the point where I was not able to see a way forward, and so I basically called it quits on that particular board. And that was also partially because I had another console stereo there that needed to be fixed, and it looked like it might be a little bit more hopeful. So I switched over to the other one. And so this next part is just me describing mostly what I did and showing some of the analysis of the circuit, again with no schematic. So I'm back again, and these things have led me a merry chase. The first one, I'm not sure it's repairable at all. It's kind of set aside for the moment. And this other one, I think I may have had a breakthrough recently, and I'm getting it together now. But this particular one, when I first started looking at it, it had sound on one channel, actually sound on both channels, but one channel was much louder and the other channel was quieter, and it was somewhat distorted and crackly. And so I found that I was going to have to get down to the actual circuit board level, and one of the first things I noticed was that this thing actually uses germanium transistors, and germanium transistors were either out or on their way out when I was in school, and that was a long time ago. So these are pretty old design. They're on, the circuits are on phenolic printed circuit boards, and there's a lot of point-to-point wiring in there, boards all over the place, really no indication of what's what other than labels on the inputs and outputs to the board. So it was challenging. I had to do some tracing of the circuit and trying to draw the circuit, and came up with a partial schematic of the actual output. And after a while I came to the point where I realized that there were some biasing problems on the outputs. And as you may realize, when you're working on stereos, the nice thing is that you've got two channels. If one channel is working, you have one that you can compare to already. but it turned out to be a resistor. And I didn't film a lot of that because it just wasn't possible while digging around in the circuit and trying to sort through all this stuff. Now, looking at the circuit here, I'll just point out a few things. As I mentioned before, there's a lot of point-to-point wiring in here. There's some phenolic PC boards, that one down there. There's one over on this end. And if you turn it up on its side, you can see the actual output transistors. Now, I wrote on there just to remind me what was what, but these are 2N4078s and 4077s. The 4077 is a NPN transistor, and the 4078 is a PNP. Those are all germanium transistors, and these two on the top are for the channel that was not performing correctly, and the two on the bottom are for the good channel. And these ones don't even use transistor sockets, so they're soldered directly in there, and in order to do some testing I actually had to desolder them. So some of my soldering and resoldering, as you can see, is a little bit rough. I'll probably clean that up before I'm done. And of course the first thing I thought of without a schematic was that these electrolytic caps here, I didn't know exactly how they were used in the circuit, but I did test them and even replaced them temporarily, and it didn't change the functioning of the circuit. So I may still replace those before I'm done. But as you'll probably notice here, I've got a 1 ohm resistor hanging off this terminal strip, and that's because that was the actual faulty component. Here's the component here. Here's the component here. It's a 1 ohm, 10%, half watt. This is a very large physical package for a half watt resistor. So here's the circuit I drew out for that side, and you'll notice the capacitor. The capacitor we were just looking at, that's the coupling capacitor to the speaker, and this 1 ohm resistor was the one right here. And I was and the interesting thing was that resistor was not open. It was about 16 ohms. It had changed value about 16 ohms, and that was enough to change the bias on this, so that it was there was always a positive voltage on this output here, and it was going into distortion when the signal coming in was driving this in the positive and the negative direction. One side of the signal was being distorted, whereas the other one was okay. Notice also this circuit uses a negative power supply. I think it was about 27 volts, and so it's got positive ground and a negative 27 volt power supply, which is something that probably some of you are familiar with and comfortable with. I don't like circuits with positive ground and negative voltages. I don't know why. It's good. It's just what I'm used to, I guess. So at that point in the process, I connected in the 1 ohm resistor, soldered it in properly, cleaned up a few solder joints, tested the amplifier with a signal in and with the AM/FM radio just to make sure that all of that worked, and I put it back into the console. Everything seemed to work. I tested the satellite and remote speaker outputs. I also took a look at the turntable, got it working in a manual mode. I believe I had to replace the needle on the cartridge, and tested it with some records, and that worked fine. I sprayed the pots to make sure they were working right, and some of the switches to make sure that they were clean, and tested it all out, put it back together, and it seemed to be totally functional and usable. Cleaned up the console, did a little bit of touch-up on some of the woodwork where it had been damaged, and took it back to the customer. So what do we say about this whole process? Well, I guess what I'm going to say is that fixing can sometimes be a bit messy, and I probably don't have to tell most of you this, but the goal, of course, is to satisfy the customer. And I wasn't able to fix one of the consoles, but I was able to fix the other one. The customer seemed to be happy with that. She's a dealer in vintage furniture and stereos and that sort of thing, and she was able to use the other console and modify it, repurpose it in a different way, so that worked out for her. I wish that I could say that every piece of equipment that I took on, that I was able to fix it perfectly and get it back to the customer in the condition that they would like, but that just isn't the reality. And so I ended up getting a partial win on this one, and that's as good a solution as I was able to come to. So in watching the video, I hope that there's some little tidbits here that is useful to you or has some entertainment value, and hopefully on the next video we have 100% success rate, but that just wasn't the reality on this one. So I think that wraps this one up. I appreciate you sticking with me through this. If there was something in here that you found useful, I'd appreciate a like and subscribe. And if not, hopefully you'll get something out of the next one. Appreciate any comments that you might provide. Maybe you have some insights that didn't occur to me. And you're always welcome to provide those in the comments. So thanks again for watching. We'll see you on the next one.